Claire and 3 friends were born on March 11th. How convenient. Leslie is 5 years younger than Claire. Mike is 2 years younger than Claire. Thomas is 3 years older than Claire. Do you want to know how old Clara is? Ask her. She'll probably tell you. But instead of knowing how old she is, you know the following fact. You happen to know that on March 11th, 2011, the product of their ages is 61,136 greater than the sum of their ages. But you do not know, I mean, this comes up all the time, right? This is very realistic, real life problem.
We have this conversation all the time. Some of our ages.
I don't know how old we are, but I know that the product of our ages minus the square root of pi is this rounded to 4 decimals. Okay.
What's the product? Like multiply?
Product is multiple. So, well, this question is good for practicing algebra, but is not a realistic thing that would come up. So we have to introduce a variable. We'll say that Clara is x. That's how old she is. So that means that Leslie is x minus 5. Mike, x minus 2. And Thomas would be x plus 3. And we have to create some sort of equation so we can solve for x. I'm going to start that equation with an equal sign. Sneaky, since it's an equation. We have to put something on both sides. We're comparing this sentence here. The product of their ages was 61,136 greater than their sum. So I'm going to put product on one side, just in words. I'm going to put sum on the other side. And then I'm going to think those aren't equal. Does it make sense that the product is much bigger? In fact, it is 61,136 bigger. So in order to make these equal, does it make sense that I would have to add the 61,136 on the right? And now I can create the algebra. The product means multiplying them all together. So x times x minus 5 times x minus 2 times x plus 3 equals the sum. If I add them together, I get 4 x's, and then putting the numbers together, I'm going to get minus 4, and then we still have this plus 61,136. Option 1 we're not going to do. Option 1 to solve this would be to multiply this all out and get an x to the 4 equation, combine all your like terms, move it over to make it equal to 0, and then use the factor theorem, remainder theorem to see if we could factor it.
Yeah, we'd be here till
we'd be here a while. Yeah, it would be like, and prediction-wise, do you think the last number in your polynomial will be big or small? It would be huge. Be big. And you'd have to try your remainder theorem for a very long time before you found something that worked. So we're going to do technology which is really nice for something like this. Whenever you have a complicated equation and you want to use Desmos or a graphing calculator to solve, what I like to do is I like to type the left-hand side into y1, into one equation, and the right-hand side into a second equation. So let's do that. X minus 5, x minus 2, x plus 3. And then I had 4x. I could combine the minus 4 and the 61,136 together, or I could just be lazy and let the calculator figure that out. Either would be fine. Now, if you hit graph, probably you won't see both graphs. A see the blue one, but I don't see the red one at all. Okay? So sometimes people try those Zoom fits. So let's see what Zoom fit would do. Seems like a thing to try. Oh. It barely fit the red one at the top. And it fit the blue one. But I don't see them intersecting yet. So I'm going to go to my window. Maybe I'll make my max higher. It was at 61,000. I'll make it 70,000. Maybe I'll change my maximum this way to 30 and see what that does. Ooh. My two graphs now intersect. If I find where they intersect, so again, second, calculate. Number 5, intersect. Curve number 1, enter. Curve number 2, enter. Guess. Here? Oh, there. And x is 17. So how old is everyone? Clara is 17, Leslie is 12, Mike is 15, Thomas is 20. And it would have been a lot easier just to ask them how old they were. Right? Even if Clara is like, I'm not telling, I'm sure you could get it out of Leslie, she's only 12. It is kind of a weird friend group as far as the ages go. Some other things you could do with the window of this one. You could probably have set your window up for the x's to be like, it's probably going to be somewhere between 0 and 100. Because they're talking about ages. It'd be kind of weird if we got an answer of, oh, Claire is 385. I would feel... But for the context of what they're asking, maybe that would be a good answer, based on the question itself being ridiculous.
Weird enough to anyway, what are on questions?
The questions for this one, if you would like more useful questions,
More equally useful questions, yes.
you can try 7